to all, good morning. Or good afternoon, wherever you are in the world, our audience. And for us, it's morning. Welcome to the speakers. And I'm happy to open this session on open science in a time of pandemic. And we will report on the experience of the Research Data Alliance Working Group on COVID-19 and try to make it, map it in the international landscape. So welcome to all. These are the speakers who will talk during this session. I am Anne Cambon-Thompson. I introduce the session, and then you will hear in this order, Natalie Harrower, Priyanka Pillai, Brian Pickering, Juan Bicarregui, and Carthage Smith. And each of them will say a word on themselves to give you more information on from which point of view they are talking. And one of the characteristics of this panel is that we have all worked together with different roles in this working group. So we have become virtual friends if we didn't know each other before. So I'm Anne Cambon-Thompson. I'm a medical doctor, emeritus research director in CNRS, and I am an ambassador of the Research Data Alliance, the organization we have been working in for this working group. And I'm also the previous ESOF champion from 2018, which was in Toulouse, and a member of the Euroscience Governing Board. And it's important to mention that because Euroscience has a number of objectives that are in common with the RDA, and specifically regarding open science and the role and responsibilities of researchers. I'm working in Toulouse in an epidemiology and public health unit. And I will have 4 points in this introduction. And the first one is basic elements on the Research Data Alliance, because you might not all be aware of what is this Research Data Alliance. It's an international organization that started its life in 2013. So not a very old one, but a very active one. And the vision of this organization is that researchers and innovators openly share and reuse data across technologies, disciplines, and countries to address the grand challenges of the society. And the mission of the RDA is to build the social and technical bridges as much as possible that enable open sharing and reuse of data. It operates with different working groups or interest groups, and there are nearly 11,000 individual members in different countries, as you can see on this slide, all over the world. So I would just want to recall the international dimension, the grassroots or the community aspect of it, and the motivation for data sharing across different disciplines, and each discipline learn from the others. So the context and the characteristics of this specific RDA working group on COVID-19 was, of course, a response by the community and for the community, which is a characteristic of RDA. There were internal discussions in RDA how to contribute in this crisis, like in many other organizations. There were discussions with different partners of RDA and institutions, and in particular, the European Commission. And it is a big push from the European Commission that actually started the idea of this working group, and that RDA should contribute through the making up of guidelines and recommendations, because there was the facts well identified. There was a need in this domain, a recommendation towards data sharing good practices in the context of the present pandemic, both for researchers and for policymakers. And this was full in the remit of and the spirit of RDA. So there were a few telephone calls and between mid and end of March to define the objective, the mandate, and the first steps of the process. And then the objectives of this working group was to towards recommendation and guidelines, detailed guidelines to help researchers and data stewards to follow best practices in order to maximize the impact of their work and to act also as a blueprint for future emergencies that we all know will probably come. The recommendations were thought of to help policymakers and funding agencies to maximize timely quality data sharing and responses in such health emergencies. And it addressed interests of researchers, policymakers, publishers, providers of data sharing infrastructures, and so on. So there was a call for action to create a fast track. It had to be faster than usual. A working group aimed at developing a system for data sharing in public health emergencies, and specifically this one, COVID-19. In less than a week, around 600 RDA members and newcomers, a lot of newcomers, registered for the different groups, because we divided the work in different groups. And there were more than 160 very active contributors to the documents that Natalie will present to you. They were experts in different fields, and some of them were chosen as group moderators. They worked on regular calls, iteration of the documents, sharing of all possible commonly shared documents, Google Docs, for example. There were weekly webinars in order to keep being connected one to each other. And there were different releases, and final release was the 30th of June. So between end of March, end of June, a huge amount of work really happened. And this was guided by the principles of RDA: openness, consensus, balance, harmonization, community-driven, non-profit, and technology neutral, which are the common guiding principle in all RDA work. There were a number of co-chairs. You will see some of them today. From different countries, different disciplines, different links with RDA. And they were very active. Every week we had a meeting and trying to steer the work of those many colleagues who all volunteered to participate. We divided the work in different subgroups, and as you can see on this slide, different research areas. Of course, the clinical domain, the omics, the epidemiology, and social sciences. And there were cross-cutting themes that also are reflected in the documents produced, which is community participation, indigenous data specificities, so there are some guidelines for that, research software, as software is so important in sharing data, and not the least, legal and ethical consideration and then for international data sharing in the domain of health. This is a whole issue in itself. So now I'm going to pass the word to Natalie Harrower, who was one of these co-chairs, and she will explain how were realized these objectives that I just recall here, clearly define detailed guidelines on data and software sharing in this context of COVID-19, help stakeholders follow best practices to maximize the efficiency, act as a blueprint for future emergencies, so not restrict ourselves to COVID, develop recommendations for funders and policymakers, and address the interest of researchers, policymakers, funders, publishers, and providers of data sharing infrastructures, as I already explained. So this global effort for raise the bar for data sharing. Let's see what it has produced now with Natalie. And I thank you very much for your attention. And I will continue sharing my slides with Natalie's slides. Your first one?
Yes, please. Thank you very much, Anne. Good morning, everyone. I'm very pleased to join the Euroscience Open Forum from Ireland this morning, a little bit earlier than some of you. So my name is Natalie Harrower. I'm the director of the Digital Repository of Ireland. So we are a data repository, a trusted data repository national in Ireland. And as Anne said, I'm one of the co-chairs of the RDA COVID-19 working group. I chaired the editorial team. So there were, as Anne explained, co-chairs for each of the areas and also moderators working in each of the groups, producing fantastic work. So part of what my job was to do was to chair the team that tried to bring this into a cohesive document, which is a challenge, but a very exciting thing to do. I'm a longstanding, I guess, active member in the Research Data Alliance through the Digital Repository of Ireland. We're one of the partners in the RDA Europe project. So I have a long history with RDA. And when this opportunity arose, if we can call COVID-19 an opportunity, I was very pleased to get involved in this group because, as I'm sure many of us feel, there's a desire to contribute in some way during this pandemic. And you best work from the area that you know well. So what I'm going to do is give a very brief overview of what's in the document. It has to be brief because the document's about 125 pages long. 70 of those are the real meat of it, and then there's a lot of references and glossaries and all the rest of it. But just to take you through some of the findings, but of course you'd have to look yourself if you want to see the detailed recommendations and guidelines. Again, as Anne said, this was a 10-week process. There were over 160 active authors working on the different sections at any given time, and really at any given time is true because this was around the world, different time zones. We had a series of releases. They were open for public comment, and then there were phases to incorporate those comments back into the document. So a very iterative, open process to come to this final release that happened on the 30th of June. Next slide, please, Anne. So in starting the document, we knew that COVID-19 was a challenge and data sharing was a challenge. But what specifically were we looking at here? What is it that was shaping the effort? So two really main things. On the one hand, a critical need for rapid data sharing in this pandemic. Things are happening in terms of research around this pandemic really faster than they ever have, as far as we know. And there's been a massive research response with really diverse outputs. And this is a challenge for the interoperability of data, both across disciplines, even sometimes within disciplines, across jurisdictions, et cetera. So there's a trade-off here, you know, the sooner the better to share data, trade-off between timeliness and precision, but you want to share the best of what you produce that can be useful for others to build on that work. That's one main challenge. The other one is that we do not have harmonized universal standards and context for sharing this kind of data. There are bits and pieces in place. The open science movement has been working very hard to try to support that, but overall there is no universal standard for sharing or pre-approved sharing agreements, and there's archaic systems in place to try to do this. So that was a challenge as well. We need to share rapidly and precisely, but we don't really have agreed pathways in place for that. So what do we do? Next slide. So as Anne said, we were looking at sharing guidelines and recommendations. As the groups were writing away, they were coming up with all different sorts of things, basing it on different themes or around different kinds of organization. But in the end, what we decided to do was to shape the document into two very fundamental different sections. One is recommendations, and what we call recommendations in the document are higher level, more generic advice that's aimed at policymakers, funders, publishers, infrastructure providers. What can you do in a broader way to support this effort? And then guidelines are much more specific detailed practical advice that's aimed at researchers, at data stewards, at clinicians and public health officials, very specific advice. So the document was reshaped along these lines so that recommendations would start for each section, and then you would also get guidelines. And then within them, there's a lot of variety because of course we have a wide range of disciplines. Anne gave you a brief introduction to what these are. I won't go into a lot of details here. Priyanka after me is going to talk about the epidemiology group a little bit more. But just to give a quick kind of overview, in the clinical medicine side of things, the timely sharing of data from clinical research, which is happening immediately on the ground, including clinical trials, it's of the utmost importance. And many clinical studies are being performed under enormous time pressure with study designs that aren't always fully optimal because of that time pressure. But at the same time, there's compelling reasons to share even preliminary results that have any kind of implication for treatment. So what do you do about this kind of conundrum? If trial outcomes are shared earlier than usual, then what you need to do is accompany those by sufficient contextual information. So those that are looking at these results can make sense of them and make a judgment about those early results and how they want to deal with them. So data behind the studies has to be available to allow verification by the wider scientific community. Again, this is a goal of open science, but more crucial in this moment. For the omics group, in order to understand the ways in which SARS-CoV-2 virus causes COVID-19 as a disease, there's research to understand biochemical processes at the cellular and subcellular level. This is crucial. This includes genomics, proteomics, metabolomics, research on the functioning of the virus, as well as its interaction with the host, and so on. So many research groups across the world are working in this area, and a major determinant of the rate of progress is the speed at which data is shared. Most of this data can be shared in existing repositories, so we have different challenges across these different research groups, and there are widely shared standards. So the guidelines here are to help point researchers in the right direction and help them navigate through the best and most efficient ways to share data. I'll skip the epidemiology in the interest of time and let Priyanka talk to you about that. Very important area, of course. And then the last research area was the social sciences. So social sciences are collecting new information, but also reusing existing data sources from online and social media as well in their research to help inform policymakers about the social and economic impacts of COVID-19. And we've all seen how heavily social and economic measures matter to managing this disease over time. And they are also assessing the success of these measures, the things that are being implemented to try to mitigate against the effects of the pandemic. So much of this research involves observational methods that produce unique data that can't be recreated in the future because of the unique circumstances. So it's important that data from social sciences are collected, managed, and preserved in ways that allow them to be reused across domains. So that's one very strong challenge, and leveraged over the long term. So this area looks at how researchers can ensure that the consent procedures, the licenses they adopt, the agreements that they use during data acquisition enable the downstream sharing of data and preservation amongst other things. Next slide, please. And then this is just a quick example. It's a snapshot to show you, if you drill down to what the guideline level of the omics section looks like. These are recommendations around suitable repositories to use for different kinds of data. So you can see the specificity here. Next slide, please. And then, as Anne mentioned before, there were also 4 cross-cutting themes, areas that really didn't fit just within one of the scientific research areas, but were overarching. And they were community, so dealing with community data. We have information on contact app tracing and that sort of thing. Indigenous data guidelines, which I'll drill into in a minute. Guidelines around research software. We realize, it's not just data that we're sharing, but it's also the research that enables us to handle that data and to do the experiments and to understand it. And then there's a host of legal and ethical considerations, which Brian's going to speak to you about. Very important, this group wrote their own section, but they also went across the entire document to make sure that we were aligned in what we were saying. Big challenge, and again, I'll leave that to Brian. Next slide, please. Here's an example from one of the cross-cutting themes from Indigenous populations and data sharing. And what I pull out here shows that depending on what research area is being addressed or theme in the document, you get very different kinds of recommendations. So with the omics one I showed you, very specific recommendations on repositories to use. But in this case, it's a step back to look at the way that that data is created and collected, and the relationship with Indigenous populations and their involvement, and the importance of inclusivity, but also consultation. So what comes out of this section is based really on the CARE principles for data sharing, which I know somebody else is talking about later. But this gives a window into one of the cross-cutting themes that really affects the way that research is conducted across all of those research areas. Next slide. I still don't see it.
Something is not working. I don't know why. I changed nothing. Okay. No.
I still see the same one.
Ah,
yeah.
You should see foundational elements.
Okay, I don't, but I kind of know them in my head by this point, so I'll do my best. I won't go through all of the foundational recommendations, but essentially the important point to say here is that, the important point to say in this case is that when we were going through all of the different research areas in the document, it was quite clear that the groups were touching on some of the same themes over and over again. Thanks, Anne, now I see it. The groups were touching on similar kinds of advice about data sharing. So we created a section called Foundational Elements, and we pulled some of the commonalities from the different areas, the 8 different areas in the document, and brought them together at the beginning. A number of these sit at the kind of higher recommendation level, but they're really key to take a look at. I won't talk to all of them, but one example, if you see number 1 there, very clear need to coordinate cross-jurisdictional efforts at open science. Governments around the world and researchers and institutions are working on open science, but often within a national context. The pandemic doesn't know those borders. So research data sharing has to be able to move across those as well. So need to coordinate and fund open science. Data and software and other research outputs need to be fair, findable, accessible, interoperable, reusable. This is a concept that's caught cachet lately, but came out in every one of the groups. Can't emphasize that enough. The use of data management plans, use of trustworthy data repositories so the data appears somewhere that others can find it, and that your data really should be as open as possible, but as close as necessary, depending on what kind of data and sensitivities you're dealing with. And I will leave it at that and move on. Sorry, that took a little bit longer, but that's an overview of the document. And thanks very much.
Thank you, Natalie. And now I'm going to call Priyanka to share her screen and to present.
Thank you so much. I'm very excited and very pleased to be attending the Euroscience Open Forum virtually, and I'm presenting to you from Melbourne, Australia. It's about 5 p.m. here, so it's almost the start of the weekend, but good morning to everyone, and thank you so much for having me here. Before I start my presentation, I would first like to acknowledge the traditional custodians of the land on which I live and work, the Wurundjeri people of the Kulin Nations, and pay my respects to their elders past, present, and emerging. And I would also like to extend my respect to any Indigenous people who may be virtually attending this presentation today. So a bit about my background. So I'm a bioinformatician and a software programmer by training. And I work for 2 research groups here at the University of Melbourne in Australia. The first research group that I work for is Melbourne Data Analytics Platform. It's a multidisciplinary group of data specialists and data stewards who collaborate with researchers across various disciplines. So our work is mainly on data-intensive research. We work with people who provide infrastructure, computation, and we also aid data stewardship and also assist in the development of high-value data collections and assets. My second work is more to do with public health, and I work for the Australian Partnership for Preparedness Research on Infectious Disease Emergencies. It's a PRIZE for short. It's a Centre for Research Excellence funded by the National Health and Medical Research Council here in Australia. And we have been working in the preparedness phase for nearly 3 years now. And this year we were swung into the response mode, making use of all the research that we developed over the last 3 years. And this research was developed by medical, scientific, public health researchers, ethics experts, and a data specialist like me. And a lot of the research are based here at the University of Melbourne. I'm also an early career researcher and observer for the Public Health Laboratory Network. It's a collaborative group of laboratories which have expertise and provide services in public health microbiology in Australia and New Zealand. My involvement with RDA COVID-19 working group was, it's truly been a privilege working with people like Anne and Natalie and all the wonderful co-chairs here. I was one of the co-chairs. I am one of the co-chairs. And I was also involved in the editorial team. And I'm fairly a new RDA member, so this was quite a pleasant surprise for me to be co-chairing a working group. But I think I could contribute a lot from the public health and infectious disease perspective. And today I'll be talking to you about interdisciplinary research, the focus of this group and how this group draws from interdisciplinary research and the various research pillars and cross-cutting themes that we have, and also draw a bit from my work and talk about how all of that contributes to the evidence base and how all of that is quite relevant and topical in public health response. And I will dive a little bit into the epidemiology theme as well. So the value of interdisciplinary research. So I've got the 4 key research areas that RDA COVID-19 guidelines focuses on and how they all contribute to the evidence base, making transdisciplinary and even interdisciplinary research a big, drawing a lot of key value from there. So clinical data and clinical research draws value and information from trials, observational and interventional studies, imaging, and healthcare data. So the data sources that I'm quite familiar with is observational trials held in ICUs. And as we know, ICUs in hospital settings is where you start seeing the first sort of wave or first sort of signals of an outbreak or an epidemic. So the value of harmonizing the fields across those observational studies, harmonizing the definitions across those observational studies, and how that contributes to an evidence base where you can aggregate data from multiple sites and draw comparisons. Omics has been, the value of omics research has been highlighted in this pandemic because genomics and whole genome sequencing studies are probably the fastest way to understand the genetic features of a pathogen and also understand the spread of the pathogen. So it helps in rapid detection as well. Epidemiology is a very, very broad term, and sometimes it's a struggle to define that specifically in the infectious disease context. But epidemiology is basically the what, when, and how. It talks about the prevalence, the risk factors, spread, severity, transmissibility, and also human behavior, which is not on the slide, but there's a lot of human behavior that goes into epidemiology studies. And the 4th key research area is the social sciences. The economic, social, and political impact. As we all know, COVID is not just a medical disaster or a pandemic or a problem here. It has impacted everything. It has impacted our lives, education, housing, employment, thus making social science a key element. And the point that I'm trying to make here is the evidence base would be incomplete without these elements, even though they're quite different from each other. The data sources are also quite different from each other, but the evidence base to make any informed decision, whether the informed decision is about interventions, closures, public behavior, lockdown, even opening up the society, it all relies on all these 4 aspects of the evidence base. And similarly, the value of transdisciplinary research is highlighted in these 4 cross-cutting themes that sit on top of those 4 key research areas. So community participation will be incomplete. The evidence base is incomplete without community. People, putting people first, understanding that people are the key element of all those 4 key research areas. So if people don't contribute that data, I'm again oversimplifying here a little bit and saying people, but if community is not with us, community is not contributing their data, the evidence base is incomplete, because that's where the real the factor is, because it's all for people, it's by the people. Indigenous data, and I know Natalie has gone through some of the key aspects of Indigenous data, but as public health researchers, we acknowledge that Indigenous communities are one of the worst impacted in health disasters, especially communicable disease disasters. And it is important to understand the community needs, understand where the data sovereignty lies, and also understand the risk factors, and not view cultural and ethical frameworks of Indigenous communities as barriers, but draw strength from those cultural and ethical practices and design interventions particularly focused on Indigenous people. The research software, as we all know, is extremely important and supports clinical, omics, social sciences, and epi data, and repositories, availability of data, and the tools and modeling and everything that we use. It all relies on research software and infrastructure that is leveraged. And legal and ethical, and I'm aware Brian would get into the details of legal and ethical aspect of the evidence base and legal and ethical aspect of research data. It is important to know that legal and ethical frameworks are not shouldn't be seen as barriers, but should be seen as an enabling framework to facilitate the sharing of data. And that's my optimism talking. I always look at the bright side and not see things as barriers. Some of these aspects are drawn from the RDA COVID-19 guidelines, but also my own public health experience. So because these systems are highly diverse, the type of data that these systems collect are quite different. It is a huge challenge to harmonize across these sophisticated yet diverse systems. And when I say harmonize, if there's a particular field of data that's being collected across all the 4 research areas, it is a challenge to harmonize the definition of those data fields. There is still no consensus about minimum information data set that's required for a public health response, not just within a discipline, but also across the disciplines. And integration of these disparate sources of data for a complete picture. And like I said, without one research area, the evidence base would be incomplete, and there would be no targeted public health intervention. There are also differences in the maturity levels of data capturing system. So a field like genomics, a domain like genomics is highly mature, and the data is quite, shouldn't say sophisticated, but gives you a lot more granular information than some of the other information systems. There's huge diversity in data models, definitions, and standards. And as we know, there's sensitivities about data linkage, accidental findings, miscalculation. And timeliness of accessing data across multiple systems makes it challenging to come up with an integrated evidence base that has information from all the disciplines. And we also need network infrastructure and researchers who can integrate these resources. So focusing a little bit on epidemiology here. So epidemiology underpins COVID-19 response strategies and public health measures. The disease epidemiology research is crucial to slowing infections, minimizing deaths, and making informed decisions. And as I said, epidemiology as a definition is quite broad, and sometimes it's challenging to pin down what exactly epidemiology means. It consists of clinical domain, surveillance, research, modeling, but also administrative data, demographics, socioeconomic, cultural practices, lifestyle, environmental data, amongst others. So the decisions about when, to what extent to impose mitigation measures, when and how to reopen society relies a lot on epidata. And some of the challenges that apply to interdisciplinary research also apply to epi, and there are obviously more challenges. So there's no international standard or coordinated system for collecting, documenting, and disseminating COVID-19 related data and metadata. There is no consensus about minimum information data set, and it also holds true for public health surveillance. So what is the trigger to declare a particular state of emergency, a particular state of disaster, what level of information is required. Making use and reuse of data for timely analyses is challenging due to issues with documentation, interoperability, data quality, methodological heterogeneity, etc. And consensus for standard definition of and reporting criteria for COVID-19 testing, reporting on testing, and testing turnaround times. I remember we struggled to understand the data sets across different countries because the testing and reporting criteria were different, and that made it extremely challenging to compare severity or even the prevalence of the disease across multiple countries. And linking epi data with clinical and genomics data is a huge challenge. And without the epi data, there is absolutely limited context to, especially genomics data. I mean, clinical would have some context there. Infectious disease modeling has been a hot topic. Everyone likes it, everyone wants to talk about it, but it is highly challenging to run those very, very, very complex models with many, many factors plugged into it, and takes huge amount of computational resources. And sometimes it is challenging to put human behavior in it because that's the most unpredictable element. And as I said, there's a wide scope of epidemiology, so it is challenging which aspects should feed into the decision making. So I like to leave with some food for thought, that we do need to make better decisions for data to improve the data for the decisions. You treat data well, the data will give you a lot. So there's immense value in breaking out of silos and combining information from different systems and domains. We need standardized and harmonized data fields, formats, and definitions for consistent decision making, and we need clear understanding of the value for synthesizing data. And this is a lesson that I've learned in the past 3 years of working in public health, that we need to build capacity for data, infrastructure, skills, people, time, funding, and collaborations during the preparedness stage, and be prepared before a real emergency hits us. That's all from my end. Thank you. I'll stop sharing my screen and hand over to Brian, who will talk to you about legal and ethical challenges. Thank you.
Oh, sorry, I forgot my microphone. So I'm happy to, thank you, Priyanka, and I'm happy to introduce Brian Pickering from the University of Southampton in UK, and he will try to explain the challenges of legal and ethical aspects in the international context we were working in. So please, Brian, and don't forget to present yourself with a bit more details.
Thank you, Anne, and thank you, everybody. It's a delight to be here, even though it's very early in the UK. My name is Brian Pickering. I work in electronics and computer science within the University of Southampton, which is on the south coast in the UK. I'd worked for many years in a global computer company, and then in the last 10 years, I returned to academia. I'm actually a cyber-psychologist, which sounds terribly fancy, but all it means is that I'm a social psychologist that looks at technology and working online. I'm also the chair of the Faculty Ethics Committee. I'm a member of the University Research Ethics Committee. I also sit on the Data Protection Impact Assessment panel. So these areas of ethics, as well as data protection, are very close to the work that I do. But in addition, there were challenges, obviously, as a researcher within psychology and social psychology, thrown up by the pandemic. And so I'm actually a new member of the RDA. I was made aware of the call and felt that, as Natalie had mentioned in her presentation, that this was an opportunity really to provide expertise and to provide time from my discipline and from my area. I was the co-chair, the co-moderator of the legal and ethical cross-cutting group. So again, as Natalie mentioned at the beginning, our responsibility was to look at the various frameworks from a regulatory but also an ethical point of view, and to bring together a set of recommendations and guidelines which would help researchers, funders, policymakers, anybody involved in trying to support a public emergency in the the best way to go about data sharing. I also worked and contributed quite a lot within the social science area, which is obviously my research discipline. So to pick up on the legal and ethical considerations, and again, as Natalie mentioned before, on the one hand, we were interested in recommendations, so for the stakeholders that we recognized within the ecosystem around managing the pandemic, we wanted to provide specific pointers as to what the important things were from a legal and ethical point of view in sharing data. But also we wanted to provide guidelines to those stakeholders to help them to decide how they should actually go about their day-to-day work, and what we were recommending as far as moving forward is concerned. And as anybody who's worked within the legal and ethical area is aware, there is this tension all the time between what is legally possible and what we would like to happen as researchers, but also as members of society. So just briefly on this working group, as mentioned before, there were 600 experts altogether who came into the overall working group to look at COVID. 165 core members worked on the set of recommendations. And as far as legal and ethical is concerned, we had a group of core contributors of 13 members. Of those 13 members, and they're listed here in italics, there were 8 new members to the group. So these are people who had never worked directly with RDA before, but nevertheless were so motivated that they wanted to get involved. The core contributors represent 8 different countries, split across 5 different jurisdictions. So we had a personal and national interest in looking at the cross-disciplinary as well as the cross-jurisdiction aspects of data sharing. In order of the number of representatives, there were 4 specific areas. Law obviously was well represented within the group, but also there were clinical researchers, Anne being one of them, and she chaired the group. Social sciences, I had colleagues from different areas of social science. And then we also had a computer scientist based in Brazil, actually, who brought her expertise on the infrastructure side. And because of this diversity of disciplines, we also had ongoing links to different working groups, so that as well as looking at the recommendations as they evolved during the iterations between the end of March and the end of June, we also had direct links into different areas so that we could bring the concerns from those areas to the legal and ethical experts to comment on and to build into a set of overall recommendations. So the objectives of the group were really split across pulling together the guidelines that people needed to consider, but also make it tangible and specific to their areas. We wanted to understand what the cross-cutting areas and interests were, and again, this was picked up by Natalie before, as part of those foundational elements to the overall recommendations. It was important to us to consider what were the things that individual researchers, policymakers, etc., would need to consider. Obviously, the pandemic, and Priyanka picked up on this, knows no bounds, either country or as far as communities is concerned. So it's very important to us to adopt this pan-region, but also pan-jurisdiction focus, and then think about who are the people who might actually provide expertise on the ground. And the scope of the recommendations and guidelines we put together was very much in a public health emergency. And so this led to a set of recommendations, policy recommendations. At the top there, obviously, is sharing data. This is vital across different disciplines because this, the pandemic, any pandemic will affect different areas of our lives. It's not just a medical issue, it's also a social issue. But also the two areas of continuous monitoring were very important. We need to be able to recognize the value of the work that we are doing and the quality of the work that we are doing, especially in an age, and again, Priyanka mentioned this, data modeling, data science is very, very important now, big data analytics, but we need, especially from an ethical point of view, to look at, to keep looking and making sure that the outcomes are appropriate. In a time of pandemic, given the scope of what was going on, one of the main recommendations was to make sure not only that we were sharing data, but also that the necessary guidance and approvals would be in place as quickly as possible. And our stakeholder group was very much, as for the rest of RDA, we did provide infrastructure guidance as well from our computer science expert. We also provide, like the rest of the guidelines, a set of resources. We list, for example, a set of statements and policies. Obviously, during the pandemic, there were different areas like UNESCO and the OECD who were coming up with specific guidance. And so it was important for us to capture those and to think of the implications. As far as the guidelines are concerned, so the second strand of what we were doing, this was brought up originally in the context of Indigenous populations. As Priyanka mentioned, they were specifically, they are a vulnerable group by definition, but also particularly affected on a medical and a social level. And so it's important for us to look from an ethical point of view at the care principles. And the care principles, if just very briefly, involves the engagement of the data subjects and the participants themselves, but also making sure that they get the benefits of the research. We recognized, and as I said, there is always this tension between the legal you must do and the ethical, what we would want to happen. We recognize and we put together a hierarchy of the kinds of issues that people must think about and the kinds of guidance that we could offer. And then lastly, I talked about seeking advice on the ground. It was also important to us to pull together appropriate guidance, both upcoming guidance, which was being formulated, but also the guidance that was already there. We concentrated on 5 specific areas. Anonymization and consent are always an issue around research data. We have a responsibility ethically. We also have a data protection imperative to protect the interests of our data subjects, to make sure that they are fully engaged. And so these were different areas that we felt we needed to explore and pull together a set of guidelines. Because it's not always necessary and it's not always appropriate, especially when you're balancing off the needs of the community and the regulatory frameworks to sit with consent. We also, in view of the importance of, this has been brought up in previous speakers' presentations, the importance of sharing research software, but also the importance of public and private enterprise data sets to look at the licensing implications and how to make sure that the data and the research software are as open as possible to engage all the community and to give them the benefit. On the infrastructure side, we picked up on the 5 safes and more recently the 6th safe, which has come out of trusted research environments, to look at what the implications were and how we would factor those into both the legal and ethical sides. And then finally, there is a section on vulnerable groups. So as well as the Indigenous populations, and to a certain extent, some of those Indigenous populations will be vulnerable. There are, and especially during lockdown, there are implications for those who need additional help in society. And we have a responsibility to make sure that they are catered for, but also to pick up on what we have to do as an imperative as researchers to bring all of those issues together. So that was a very high level view of what we did in trying to pull together guidance and to recognize the regulatory requirements around data sharing. But I also just lastly wanted to pick up what the RDA is all about. As mentioned before, there were a lot of people who gave their time and their expertise to come together to do our bit, as it were, during the pandemic, and the Research Data Alliance provided the environment for this. Specifically for us, as I said, there were 8 out of the 13 core members contributing were new members to RDA. This is both an indication of how important the pandemic is, and we all realize that, but also that there are experts there who need an environment to come together and to share their expertise willingly and openly. But what this has led to, and I think this is one of the big strengths of the Research Data Alliance, we now have a network of different disciplines. We know each other. We've got, it was talked about before, we are virtual friends, but we are also experts in different areas. And we are now used to working across the globe and working across those disciplines to understand each other. And we've taken this further. This is not necessarily a plug, but this is just one example of where we're moving forward to bring the ethical, the technical, but also the legal issues around a decision that was made by the European Court of Justice recently, Schrems 2, and this is about data sharing and restricting data sharing. So we've taken forward what the RDA provided as far as a cross-disciplinary collaboration environment to look at issues that are real and that are current, and to be able to take forward what the RDA has given to us as experts, and to feed back to the community with what we have. So I'll leave it there, and thank you for your attention.
Thank you very much, Brian, for your testimony, I could say, from this work. And I'm happy to call now Juan Bicarregui. We stay in UK with you today, and you're going to present more yourself. And I just want to say that you have 2 hats in this panel, and many others. But one is that you've been a co-chair of this working group. And on the other side, you have important roles in the European Open Science Cloud. And so you will confront this internal experience of this international working group and your European responsibilities and spirit to it. So please, Juan, thank you very much. You can share your screen.
Thank you, Anne. Yes, I can share now. Okay, thank you, Anne, for the introduction, and thank you for the invitation to speak here. Yes, I'm Juan Bicarregui. My main job is at the Rutherford Appleton Laboratory, which is the national facilities in various areas of science, mostly around physics, chemistry, biology, where we have some large facilities, synchrotron and neutron sources and large lasers. And I'm in the scientific computing department there, where I'm head of data division. So looking after a lot of the infrastructure that manages the data coming from those facilities. So I'm also a member of the European Open Science Cloud Executive Board. I was the coordinator of the EOSC pilot project a few years ago, now chairing the working group of the Executive Board on rules participation. So in that role, I'm trying to steer the work of the European Open Science Cloud, which is a large collection of many, many different European projects. I expect many of you know about it. From a board of some 11 members. I thought also worth mentioning that I was a member of the RDA, well, I am a member of the RDA Organizational Advisory Board, and was co-chair of that board from the start of the RDA in 2013 for the first 4 years. So yes, I come at this from many different angles, and in thinking about what I would try and present today, I thought I would take a pretty high-level view and just try and look at the objectives of the RDA working group, the really fundamental objectives like that Natalie talked about earlier, and the objectives of the European Open Science Cloud, and see where they meet and see where we are today in bringing those together and seeing where we might be in some years' time. So I'm not going to give a formal presentation of what European Open Science Cloud is. As I said, I think a lot of you probably already have a fairly good idea. I'll just give a very personal perspective about perhaps the cultural change that European Open Science Cloud is trying to bring about. And I'll couch this in terms of the research lifecycle. So here we can see a very traditional research lifecycle where I forced each stage to begin with the letter C. It's slightly contentious ways, but anyway, we can imagine that a piece of research starts by a group of researchers getting together and forming a collaboration to undertake the work. They'll set up a hypothesis and some experiments or whatever, and looking at this purely from the data point of view, they'll create some data or collect some data. They'll put that data somewhere in some sort of capacity storage. I'll do some analysis and computation on that data, curate the results of the data, hopefully, and collect together perhaps with data from other sources, and eventually communicate their outputs through papers or other means. And then that communication will trigger new collaborations, and so the life cycle goes around and around. And in the Open Science Forum, well, the upper part of that is where open access to papers will help. The lower part of this cycle is all around opening up the data, and the whole thing is perhaps the open science life cycle. Now, what we're really trying to achieve with open science isn't just renaming and changing, but we really want to fundamentally change the life cycle. And one of the ways we wish to change that is to communicate the outputs of the research at every stage. So this meets the rapid data sharing idea that Natalie talked about. One of the needs in the pandemic, and one of the goals of open science would be that we share each stage in the research before as it becomes available, so that we don't need to wait for the publication of a paper. Obviously, there are issues there around recognition and reward and intellectual property and the like, but really the driving impetus comes from this idea that the sooner we can share the outputs of research, the better. Why is that better? Well, because that will make collaborations happen at earlier stages. If somebody can use your data as soon as it's collected to do a different piece of research, why should they have to wait until you publish your paper so that they can then get the data and then use it in a different way, as an example. But these arrows really make things a little bit complicated, so actually you can simplify the whole picture by taking collaboration and communication out of the cycle part and putting it in the center, saying, well, when the data's created, it's put in some shared environment so that it can be used by others. When the computation is done, maybe when the software is written, even before the computation is done, and when the data's collected, everything happens in a shared and an open way. And that central thing, I call it open data science environment, which is a phrase that was used by G7 a few years ago. But within Europe, that equates with the European Open Science Cloud being the infrastructure that will allow that sharing throughout the data lifecycle. And as you see, that fits very much with the kind of thing that we've been trying to achieve in the RDA working group. Rapid data sharing, interoperability of data is obviously essential if it's going to be picked up and used elsewhere. In order to achieve that, we're going to have standards for that sharing. We're going to make the data available at all stages, etc. These are exactly the objectives that Natalie was giving for the RDA working group on COVID, and they're also the objectives for the European Open Science Cloud. So in a sense, that's the easy part of my talk, to say that the two groups align absolutely perfectly. But let's think a little bit more about this. So I'm going to ask two questions. How would the work of the RDA group be different if the European Open Science Cloud were available today? Well, it is available today. It's in a development phase at the moment. So we could say, where are we and what will happen in the next few years that will make the work, this kind of mass collaborative global work easier through European Open Science Cloud in the next few years. And then looking a bit further ahead, once the EOSC is established and being an infrastructure, we expect others to build applications on top of it. What would the work of the RDA group be like maybe in 5 to 10 years' time? So the current phase of EOSC, I call it an infrastructure development phase. And what are the tools we are developing that would be of use to the RDA working group? Well, there are certainly a lot of collaboration tools. There's identity management, document sharing, communications tools that will be part of EOSC. The RDA group, we're using Google Docs extensively. That's an extremely useful tool. I'm not going to undermine it in any way, but it isn't really integrated with the other tools that researchers are using. So maybe we could have a better solution to that. We were using the RDA mailing lists, again, fairly independent means of communications, not really linked in with the other parts of the infrastructure. An important aspect was the bookkeeping, the recognition of contributions. We spent quite a lot of time talking about how we would make the appropriate recognition of the different contributions that were made to the work. RDA has its own sort of norms for that, which had to be slightly adapted because this was a rather unusual working group because of the rapid work that was done, the rapid need, the need to do the work very rapidly. So another area where EOSC hopefully will in due course change the culture was around the recognition of contributions, so that it wouldn't be such a big, so there won't be such a big issue whose name goes on the paper, because the contributions are recognized at every stage in the research lifecycle, not just in the writing papers. Then, excuse me. Another area where EOSC was developing tools at the moment is around referencing and access. Obviously, a large part of EOSC is about federating the existing infrastructures, so the existing data repositories, of which there are many, and there will always be many. Nobody is talking about putting all the scientific data in Europe in one repository. That would be almost impossible and actually not even desirable, because it's good to have specializations. But being able to search across different repositories in a sensible way is obviously a good thing. So those integration of repositories and the definition of the various APIs that will be necessary to make that happen well is part of the work. And that could have assisted a lot in the work of the RDA group. One reason why it was really helpful to have such a large group was because that large number of people bring large amounts of expertise. One of the objectives of EOSC is to broaden how much of that accessing of the right information can be done automatically through these integrations, so that the search could go across repositories. You may not need to ask a human. That's becoming a bit more difficult to get to. A lot of the document is actually about referencing the various data sources, documents, etc. We have a fairly good system now with DOIs and URLs and things to make identifiers to different resources. But again, many different systems out there not really coordinated. That's one of the areas which EOSC is trying to help integrate and converge. Another area where hopefully the EOSC would have made the work of the group easier is around assessing of quality. A lot of the work in the group was to bring expertise of the individuals in to play in order to judge which are the best repositories for which kind of data and whether data is indeed valid. One of the things we're trying to do, and here I want to distinguish quality and value. I say quality of data is about the sort of quantifiable metrics in terms of reliability and errors and all those things, whereas value, of course, is a scientific judgment. And we're not trying to bring in measures for the scientific value of data, rather just be able to understand that if you're using a resource on EOSC, you will understand what the quality of that resource is. The quality of repositories through systems of certification like Core Trust Seal is also an important aspect here, so that if you are collecting data from a repository, you know what you're getting, both in terms and to distinctly whether you know the process that's gone through in order to get that data into the repository, and also the quality of the data itself, the product. So that's really kind of what EOSC in the next few years could have, if this pandemic had happened in 2 or 3 years' time, how would EOSC have made the work of this working group easier and more effective? If we look further ahead, 5 to 10 years out, once EOSC is established and there has been, as an infrastructure, and there's been time for innovators and researchers to develop applications on top of EOSC, what could the work of the group have been like then? So the fundamental question here is to ask, to what extent could the work of the working group be done automatically in that environment? And we have to say, well, what really was the value of the working group? As I said already, having a large group of people was really helpful because it brought in all that expertise. If we really did have machine readable and understandable systems built on open data with machine learning and AI, to what extent could that collection aspect of the work bringing together have been done automatically? That's a fundamental question, but it's certainly an ambition of EOSC and other initiatives, similar initiatives in the US, for example, would be to enable AI systems on top of the machine readable open data to be able to do things like collection of the best sources for particular questions. And thereby, so what we did with a huge human effort at the moment, collecting lots of recommendations, lots of data sources, classifying and collecting and categorizing, perhaps that could have been done automatically at some point in the future. So the output of the working group is essentially a reference text. It's a large collection of information, and any individual is unlikely to need to read the whole thing. They're much more likely to look at particular aspects. For example, Carthage, after me, will be speaking about the policy aspects of the recommendations, whereas Priyanka was focusing very much on the epidemiology. So any individual is only likely to look at one part of it. We are in the working group now developing a tool that will enable the that navigation of the document in a much easier way, incidentally. But really, could the whole of the reference text be replaced by an AI system where you ask a question, maybe then get a set of responses, refine the question, and get another set of responses, refine it a bit more till you actually can define a question that gets you exactly the resources you need through some system? Well, yes, hopefully. I think that's one of the ambitions, is that by laying out all the data in a machine readable open way, such systems that will enable the kind of work that was done by this group to be done by individuals as a series of queries, rather than by 100 people spending 6 frantic weeks collecting together work. Possibly, this is a kind of open question for discussion, but and it's not to undermine the fantastic work that was done and was needed today, because we do not have the OSC and all the things that will be built on top of it available at the moment. So that's really all I wanted to say. I wanted to raise those questions and make us think a little bit about how this kind of emergency could be dealt with in future when we have the fullness of open data and open science working. So thank you very much.
Thank you very much for your contribution, thoughts, and vision of the future. And now it's my pleasure to call for Kartaj Smith, who did participate in the work of the working group, and is from OECD and working on policy documents at OECD level. So it's the vision from an OECD point of view and experience that is going to bring to this table, and addressing particularly the issue of translating the RDA guidelines into policy action. How does it, is it possible? So please, Kartaj, that's your turn now.
Hello, good morning, everyone. So, like everyone else, I'm delighted to be part of this discussion. Privileged, really, to have been able to follow the work of this working group and to discuss what it means for policy actions. My name's Kartaj Smith. I'm from something called the OECD Global Science Forum, which is a forum that brings together people from science ministries and funding agencies in OECD countries, and looks at science policy. I think in the context of the work that RDA has been doing, as was said at the start, it's a community-driven activity, if you like, bottom up. You've come up with foundational elements, recommendations for policy. The real issue then is how do we turn that into policy action? From the OECD perspective, we have been working top down on many of the issues that reappear in your foundational elements. So OECD produces what we call recommendations, which are soft law. And we have recommendations around privacy and access to health records, for example, around principles for AI, around enhanced access to data from public funding. So we have these high-level principles, and we have your, if you like, the RDA bottom-up community-led exercise. And a question in relation to COVID, where we really have to act quickly, is how do we turn these things into actions? And how does the policy community work with the RDA community and others to really make things happen quickly and effectively? So who do we need to act? We need governments to act, including health authorities. Across the whole of government, we need some actions around the sort of data that is needed for research. Research funders obviously have a critical role to play. I think universities and research institutes have a really important role to play, and then obviously the academic community. And in some ways, all of these actors are also policymakers. In fact, in science, much of the policy is made by the academic community, or at least the academic community has a major say, for example, in what the funders do, and even in what the science ministries do. It's also critical that we coordinate and we cooperate across the different sectors, disciplines. We've heard about operation. We also need to think about the private sector, and obviously COVID is an international pandemic, and we need to think how we can work effectively internationally. So what is required from these different actors in their policy roles? So we need leadership and support. These are very high level. We'll get into a more detailed analysis later. We need wise investment, so strategic investment in research and in the infrastructure and human resources around data. We need to promote the enabling conditions for fair, responsible, timely access and the tools related to that. So it's not just about data. Software was also mentioned and is absolutely critical. The data on its own is no good without the tools and the infrastructure to use it. And then a critical issue that we're all involved with is how do we have transparent data governance that promotes trust, that promotes public trust, that promotes trust across the science community. So we need to integrate policy actions across the research data lifecycle. This figure is similar to what Juan showed earlier. It's a different representation of the policy life cycle. But if we think of the different steps of this, rather than often what we think about is just the share and reuse part at the end. But in fact, we need to think about the whole of the data life cycle. So if we start with the planning and designing of experiments of our research, we've talked about data management plans. We in OECD recommendations, in the RDA work, we say promote data management plans. I think the time has come in the context of COVID to mandate data management plans. Ethical review and approval. Yes, we need to expedite that, but at the level of, for example, of institutes, that means that they have to have properly constituted ethical committees that have the data expertise on them and the resources and the conditions that they can actually expedite the ethical review. So it's easy to say, but it requires actions. And again, licenses and agreements. We have many of the those licenses exist. We need to share the data that is in the guidelines coming from RDA. We need to make sure that that is available to researchers. We need experts in institutions advising people on the licenses that they are using and making sure that they are used. So we need support mechanisms around these licenses and agreements within institutions. Funding agencies and others need to make sure in data management plans that the license agreements, etc., are being addressed. If we're looking at collecting and creating the data, this part of things, so we talked about the FAIR principles. In a way, it's now about putting the FAIR principles into action. And of course, that is really what the RDA guidelines are about. But we need to provide the resources, the support from the funding agencies, from the institutions to make that possible. In particular, the expertise. We also we talk about, for example, obtaining and tracing data provenance. So a lot of that is about identifiers, unique identifiers, etc. We need to start to make sure that those things are open and are used routinely. We need to move from the language of this is what we need to actions. And in the context of COVID, if ever there was a case where we can justify those actions, then COVID is surely it. When it comes to analyzing and collaborating, so here there really is a critical role for governments and the agencies at the highest level. We need to coordinate across the sectors and the jurisdictions. Need to agree on the frameworks that we're using, many frameworks. we to what is coming through from the RDA work. And again, we need to, with regards to software, again, we need to include that in our data management plans. Certified repositories, we talked about repositories. We need to move from the step of saying we should promote them to actually mandating the use of repositories, and many of these are listed in the guidelines from RDA. And on sharing and reuse, again, we need to put into practice many of the recommendations and guidelines that are out there. We need to make sure that we have the structures, ethical committees and others that make sure that those things are actually in place from the outset. And this issue of recognizing data as a first-class research output, again, in the context of COVID, I think we need some discussion about how we do that. But it's actually, it's critical that from the outset, one of the outputs of research that we expect from COVID is the data, and that data is duly valued and credited. And all of that really depends on building on existing data infrastructure, investing wisely across all disciplines to make sure that we have the infrastructure, the human resources that we need to really make the guidelines that are there in the RDA principles to make them come alive. And again, that's a shared responsibility, but it needs action. We have the principles, we have the foundational elements. We need to really now turn that into very practical actions in the context of COVID-19. If we can do it in COVID-19, then it obviously has broader implications for the whole of science. I know that time is tight, and so I'll stop there, leave at least a few minutes for discussion, and hopefully I said a few things that will inspire some questions and further discussion. Thank you.
Thank you very much, Carthage. And you started actually the discussion. I think that I will just share my screen to thank the audience and tell that even if we have a very short discussion time now, we do have a possibility to continue because we have a press conference on Sunday at 10:30, the time in Italy, and the link that I will just now show on my slide, if I can share my screen. Yeah. Yes, you can see the link to connect to that press conference, and this is an open link. So even if you are not a media person, you can actually come and potentially ask questions. And several of the speakers of this session will be there for this press conference on Sunday. So now I'm going to see if there are some questions around the notes and the discourse we have had today. You have all understood that it is an extraordinary experience, this working group, and we have a critical eye on it now because it's, I will stop my sharing now, people know that. And if, I don't know if there is some questions from the audience, but if not, which I think is the case for the moment, I would like to ask, for example, Natalie, how do you see this working group as compared to many other working groups of the RDA? Was it special? What is your view on that, Natalie?
Well, as an RDA member, I can say for sure that all the working groups were special, but no, there was something very different about this. I mean, you know, there are pressing problems to address in data sharing in a number of different areas, but this was a unique example. And so the way that it came together and the energy and the level of input, people were working at a very fast pace. I think we actually exhausted some people, but they willingly did it in order to get those drafts out, to incorporate the what came in from the public consultation, which was generally positive and very specific. We didn't get any feedback that had major problems with anything that was being discussed. So the levels of coordination, the fact that the working group had many subgroups within it, and different ways of bringing people together, the number of meetings and the way that it happened in different time zones, it really took advantage of the world's different time zones. So I think there was a passion and an energy and a willingness to put in extra time in this group that you wouldn't normally see when we're able to work at a more reasonable pace. But nothing feels fast enough with the pandemic. And I think researchers are facing that kind of pressure. Clinicians, hospitals, governments, everyone is facing, parents with kids, like everyone's facing this kind of pressure. But the group really responded. So it was an unusually rewarding experience. I'm so happy that I was able to be involved in it, despite the lack of sleep.
I think we all are, but you also know, and both Juan and Carthage have alluded to it. If guidelines and recommendations are not used, they are of no use. And because of this huge amount of work that has been put by so many people, I would like to see, for example, Priyanka, how do you see, with your experience in the group and outside the group, the impact in the long run of these guidelines and recommendations?
Thanks, and that's a really good question. For me, being a part of this group was very rewarding because it then puts all my abstract ideas and aspirations that I had in the preparedness phase, and it gives an actual framework to the ideas that I had. I'm, again, not taking ownership for all the intellectual inputs there, but there was a lot that was going on in my head, and I was talking to researchers, and it was all quite abstract because no one knew what they would look like in practice, the gaps, the challenges, the recommendations, what they would look like in practice. And being a part of this group and in the middle of a pandemic has made me realize how important these guidelines are. So ideally, I would like to see an infectious diseases working group that emerges from this, and we focused not only on coronaviruses but other diseases as well, and leverage some of the work that's done in the influenza space, because influenza surveillance is one of the most mature surveillance systems around the world, and maybe replicate some of that work and have much more sophisticated systems in place to respond to the next threat.
Thank you, Priyanka. And we have 35 seconds left. So in 30 seconds, can you, Brian, tell us if you have some hope that the international sharing will actually benefit from the work that we have been doing?
Certainly, very quickly, I think what the RDA actually did was bring together people with an infrastructure, and then people felt really motivated to become involved and to be able to share and bounce ideas off each other, which was actually very stimulating, and it puts us in a good position in our own research, but also in moving forward. So I'm very positive. Okay,
thank you very much. I think our time is over. Thank you very much, all speakers, and I give you a rendezvous to the press conference if you want to hear more questions and more thoughts about this work. Thank you very much. Bye-bye, and thank you to the audience.
Bye-bye, everybody. Thank you.
Thank you, everyone.
Thank you. Bye-bye.